Welcome to a new test and teardown video. This time it's a signal generator J3 from Advanced Instruments. The fun thing about this one is that we got balanced output. See, I think there's this CT here means center tap. So there will be an output transformer with a center tap and then positive and negative drive. And then you can of course change the level on that output. I don't understand exactly that line, why that goes to the meter, because I think the meter goes to that pot. So this is the variable sine wave output, and that is referenced to chassis. And then there is a square wave output with a variable level. And then of course we got the normal frequency ranges. So it should go from 10 Hz to 100 kHz. But there's a little funny thing here. Minimum, if you're in times 1000. Okay, that is interesting. I think this generator is from about the 1990, so it's quite old. Old transistor, of course. They exist in different models or versions. This one is the one with only low distortion output here, and it's not with the one with the battery connector, so you can run off a battery. So let's try and power this up. I've connected all 4 channels here. Mains input. We got a little bit of light in the LED, and oh, we got a lot of output. That is interesting. So that is definitely, I need to play a little bit with that. And let's adjust the different channels a little bit. So we got, the variable here affects all sine wave outputs. Okay, that's interesting. Well, this is maybe also what it shows. And then I got an attenuator for that. And they should be in the same kind of, what is going on here? Channel 1 is 5 divisions. Channel 2. Did I set up something wrong here? This is probe times 1. No, I did not screw this up. There is a weird thing going on with this output and the center tap. As you can see here, the output is not centered. So what is going on here? Look at that. 1 volt per division, 5 volts per division. So there's way more than the other. So those are not a balanced positive negative, or at least there is a symmetry kind of problem, or something is not as it's supposed to be. So that is what I see here. And that is the square wave goes all the way to 0. Okay, perfectly fine. But the variable here is all of them. Okay, so what is wrong with this? Minimum times 1000. So let's try and do that. Okay, there's a little bit. If this is, no, it's not minimum. And here is 10. It says 10 here. And look at that. This is 10 kilohertz. So, of course it works. a little bit unstable, this switch, but that is a classic. I'm going to look at that when I get deeper into it. Well, look at the frequency here. How accurate that is. Definitely good. So that is not a minimum of anything. So let's look at the maximum, if that is accurate. Let's go for the dial indication first. Here it says 100, like that, right? And here we go, 96. So that's quite accurate, and it can even go to 106. That is of course correct, because that is written. All right, so I think it definitely works. So that was the maximum frequencies. Let's go all the way to the minimum and see if there is any output here. It is exactly the same output, and that is a 104 Hertz. And then it should of course go all the way to 10 Hertz. Right? 10 Hertz. And we got exactly the same output. And I don't know about you, but that frequency is 10.2, right? So that is quite alright. Let's have a look inside, shall we? Just so I don't forget to tell you guys, the power consumption is 8.7 watts. This is so classic. Look at the lid. See, instructions about how to open it is also written with a permanent marker. I mean, this is just so classic for my father and all his equipment. And also those notes. See, here is some oscillations problems in the output transformer, and you can make this happen with the -20 and -40 dB switches if they are out, and if you change fast from 10 kilohertz to 100 kilohertz, then this behavior can happen. And it also says here transistor 164 in the power supply. That was changed in 1998. Cool note, huh? So he had this one for many years. And here's the fuse, just so you know, if you're looking for it, it is right there. But I was actually looking for the bulb, because I was expecting this type of oscillator to have a bulb in its level stabilization system. But I can't find this bulb. Maybe it's in here. But in here, I mean, how do I get inside this box? That is also a mystery so far. I see this really cool geared drive for the frequency setting, see? We got the level pots and the meter. And here's another fun thing. So let's see that. There's a screw missing right there. And for some reason this one is not going all the way out here, but that screw here is mounted. So maybe this whole unit was taken out. Or maybe that is a trick to get in this unit. Let me take off the bottom plate and see if we can see more. 164. Oh, that is funny, isn't it? I just look straight to it. That is transistor 164. That was changed. Good find. And we got some other capacitors mounted, probably for some adjustments. So there's a capacitor there on the back, and also here. Ooh, I also see another little capacitor too. Other capacitors here on the back for fine-tuning of stuff. So maybe this is why it is so accurate. That's of course the mains transformer. So that will be some signaling transformers, I would assume, right? It was just as easy to remove the bottom cover. And now I see this unit was definitely recapped, or at least some of them. Look at that, so all those are new. Those are originals. I think this is also original. So we got some signaling diodes and all that kind of stuff here, but still haven't found the bulb. So maybe this kind of oscillator don't really have it. I don't know. So far, I just haven't found it. So that looks like a output power drive. I think this is how we get into that funny case, and I also see signs that prove somebody was in here before me, really. Look at the details here. Oops. And this is correct. And of course I found it. It was not that difficult to remove this lid. It was, you slide it back until it hits the transformer, and then you're almost okay. Then you can squeeze it out. And what do you find? The bulb. So of course there was a bulb. I said it. I knew it. This one looks a little bit. And here is a field effect transistor. No. Could also be a normal. I haven't actually seen the schematic so far. Ooh, somebody was soldering on that one. That looks a little bit weird. But anyway, here's the bulb, and we see a little bit of modifications. A capacitor on top of that capacitor here. That looks a little bit weird, right? Probably some fine adjustments. And I'm not going to touch anything because it really, really works super, super good. And here is the frequency settings, all the different ranges. That is a very long. It's probably done because of the super high impedances or what, but it's not that high, is it? Maybe it is, because here is the variable capacitor for frequency settings. But yeah, it is definitely a beautiful unit. There isn't really a lot to say about it. I will try and see if I can find a screw for this missing mount. That is kind of all I wanted to apply to this unit. Then I'm quite happy about it. So thank you very much for watching, and see you soon, alright? Bye bye.